Hello guys, hope you all are doing well. Welcome to my channel, Accidental Teacher. Don't forget to subscribe it. Today in this video, we are going to do some number programs. Hello friends, welcome back to my channel. Today we are going to do the part 4 of number programs. I'm going to do some programs where we are going to use different techniques. We are not using breaking the number technique anymore. So we are going to do some new programs. So let's start. The first program today we are going to do is perfect number. So let us understand the program first. A perfect number, a number is said to be perfect if the sum of the factors, now be very careful over here, sum of the factors excluding the number itself is the same as the original number. So we are supposed to find the factor of some numbers, a given number, but we are not including the number. So one example 6. So factors of 6 is 1, 2, 3 and 6, but we are not including 6. And for those of you who don't know what is a factor, factor means, like suppose we have 6, factor is 1 because 1 can divide 6 exactly. That means whenever you are dividing a number by another and the remainder is 0, the second number is the factor. So 1 can exactly divide 6. 2 also, when you are dividing 6 by 2, remainder is 0. When you are dividing 6 by 3, remainder is 0. And when you are dividing 6 by 6, remainder is 0. So basically we are going to use the logic of remainder. That means the mathematical operator used over here will be modulus. And we are excluding the number. So 1 plus 2 plus 3 is 6. So we get the original number. So very important things that we have to notice. Number one, we are not including the number, original number. And second, we are adding up the remaining of the factors and checking whether it's same as the original number. So over here the technique is very different than breaking the number program. So let's have a look. I have taken a variable I to use that in the loop, variable n to get a number from the user, and s to calculate the sum of the factors. And I have taken the value of n from the user. I have made a loop over here, and the if statement over here is n modulus I equals to 0. So n is the number and I is the loop that starts from 1. Very important, see, starts from 1 but ends at n minus 1. So over here equal to is not there. That means the number n is not included. So except the number, all the other numbers lower than starting with 1 is included, and check over here whether it's a factor. If it's a factor, we are adding it. If it's not a factor, we are not doing anything. We are again using the loop for the next number after incrementing it by 1. So if we explain this part, I'll just show you the dry run over here. Let's take the example of the number 6. So n over here is 6. So I equals to 1. So I'll write down I equals to 1. And s sum is set as 0. So it comes over here in the loop, in the for loop. I have used for loop over here because we need implementation as well as initialization and all those things. So it's better to use for loop, but it can be done with while and do while as well. But it's easier to use for in this type of program. So if n modulus I, so n is 6. 6 every time the value of n is 6. So let us just say this term as 6. 6 modulus 1 equals to 0. So whenever you are dividing 6 by 1, is the remainder coming 0? Yes. So that means it's going inside the body of if statement. So s equals to s plus I. So s is 0. 0 plus 1. So the new value of s will be 1. And then the loop is over. Again we go back to incrementation. Okay, I hope you know how the for loop works. So first initialization, then condition, then it goes back to incrementation, again back to condition, and this way it creates a loop. So the value of I will increment now, it will become 2. So when the value of I is 2, the condition is again true. And it comes over here, 6 modulus 2 equals to 0. So when you divide 6 by 2, remainder is 0, again 2. So sum equals to sum. S is 1, 1 plus 2, new value of S will become 3. Again we will go to incrementation, the value of I becomes 3. The loop is true again because 3 is less than 6, true. 6 modulus 3 equals to 0. Again true because 3 can divide 6. Exactly. So over here what will happen? Sum equals to sum plus I. Sum is 3. 3 plus 3 is 6. Now what will happen? Again it will go up, the value of I increments, now the value of I becomes 4. 4 means, again the condition of here is 2. Now 6 modulus 4 equals to 0. Now when you divide 6 by 4, remainder is 2. So is 2 equals to 0? No, false. False means don't do anything over here, don't go inside the body of if. Rather you come out and then go back to implementation. So now the value of I becomes 5. So 5 is less than 6, again true, go inside the loop. Now 6 modulus 5 equals to 0. Now when you divide 6 by 5, remainder is 1. So is 1 equals to 0? No, false. Again no addition over here. Again go back, implementation. So now the value of I becomes 6. Now 6 is less than 6 because in is 6, 6 is less than 6 is false. So over here the loop gets over. Now if you notice, after the loop is getting over, the value of sum stored over here is 6, which is the addition of the factors 1, 2 and 3. So after the loop is over, again the if statement, if n is the number was 6, is 6 equals to s is also 6. So the condition becomes true. True means it is a perfect number. And suppose the numbers are like, suppose any other example like 4. So what are the factors of 4? 1 and 2. So 2 plus 1 is 3. So is 3 equals to 4? No. So for those type of numbers, it will go to the else statement and display it is not a perfect number. So this is how we do the program for perfect number. I hope you have understood. The second program we have is the prime number. Now most of you already know what is a prime number because we have been learning this in mathematics for a long time. But even then I'll just let you know. A number is said to be prime if the number is divisible only by 1 and the number itself. So basically what this means is, I have given some examples also, 2, 3, 5, 7. That means a number which has 2 factors, only 2 factors, those numbers are known as prime number. Why did I tell you this thing is because when you are doing programming, we have to implement the thing called factors, the rule, how we found out the factor. In perfect number program also we did that. So factors are found out with the help of modulus. That means a number is a factor of another number if it exactly divides the number. That means when the remainder is 0. So the program is done over here. I have taken I for the loop, n is for the number, and c over here I have taken for the counter. So c over here is the counter variable. So it will count the number of factors a number n has. So if the factor is 2, it is a prime number. If it is not 2, it's not a prime number. So over here, I have made this diagram. So with the help of diagram, I will be explaining it. So I equals to 1. So let us write I equals to 1 and n. Let us take any prime number, like suppose let's take 5. Okay, so the value of I is 1. So the condition over here is true. And I have used less than equals to n. I have included 1 as well as the number. So the factors of a prime number will be 1 and the number, nothing other than that. So let's check that. How will we check that is with the help of if statement. So in the if statement we have n modulus I. So I will start from 1, 2, 3, 4 till n. So every time it will increment and then every number will be checked whether it's a factor or not. So if it is a factor, the remainder is 0 and it will be equal to 0 and the counter variable increases its value. So first over here we have got the counter variable CR right over here. So counter variable first value is 0. So when we come over here, we know 1 is a factor of all the numbers. So 5 modulus 1 equals to 0 becomes true. Then the counter increases by 1. So C++ I have used over here the postfix which increases the value of C by 1. Next again it goes up. The value of I changes to 2. So the condition will be true till the value of I is 5. So the condition over here is also true. Again 5 modulus 2 equals to 0. This is false because when you divide 5 by 2 you get the remainder 1. So it will not go inside. Again it will go up. The value of I changes. It becomes 3. Again 5 modulus 3 false. Then the value of I changes to 4. The condition is true. Again we check over here. 5 modulus 4, again the condition is false. So we are not coming over here. Again we increment the value of I. Now the value of I is 5. So 5 is less than equals to 5, again true because we have equal to. We are including the number also. Unlike the perfect number program. So we have 5 modulus 5. Obviously, when you divide a number by the number itself, remainder is 0. So the statement is true, the counter variable value becomes 2, increment by 1. Then the value of I becomes 6. When the value of I is 6, the condition becomes false. 6 is less than equals to 5. The condition is false. The loop is over. Now after that, if you notice, over here, the value of C becomes 2. That means the number 5 has 2 factors. So it's a prime number. So after the for loop is over, if C equals to 2, it's a prime number. Else, it is not. So you understood when the number is prime, what is happening. So I'll give you one more example quickly, which is a number taken which is not prime. So let's take one example. Like suppose if the value of n is 4. So everyone knows over here that 4 is not a prime number. So we'll take the values of n as 4, I will be 1, C will be 0. So we are doing it once more. Now 4 modulus 1 is 0. So the counter variable increases. So C becomes 1. Then the value of I changes to 2. Now 4 modulus 2 is equal to 0. Again it is true. So again counter variable value increases, it becomes 2. Then the value of I changes to 3. 4 modulus 3 equals to 0. False. It will not go inside. The value of I changes again. It becomes 4. Now when the value is 4 modulus 4, again it is true. That means the counter variable, the value changes to 3. Then the value of I becomes 5. So when the value of I is 5, we know the loop will be over. Now if you notice over here, the counter variable has 3. So whenever it's not a prime number, the factors will not be 2. It can be anything other than 2. So over here, the condition C equals to 2 will be false because C is 3. So it will go to else and it will display it is not a prime number. So this is how we do the prime number program. Now one more thing I would like to tell you over here. Some of you who don't know what is composite number. Composite number is a number which is not prime. So it's just the opposite. So it is just the opposite of prime number. So suppose the question comes in place of prime number for composite number, what we can do is very simple thing. Just over here, wherever you are writing it is a prime number, you can just write down it is not a composite number. Wherever you are writing it is not a prime number, over there you can write down it is a composite number. So with one program you can solve both composite as well as prime. And other thing what you can do is in the if statement you can write down C is not equal to 2. It is a composite number. Else it is not a composite number. So we can do the composite number program as well. So this is how we do the second program, prime number. The third program today, what we are going to do is we are going to do HCF, which is also known as GCD, and LCM. So in one program we are going to do two things. We are going to find the HCF as well as LCM of two numbers. So before that, let us understand what is HCF and LCM. Most of you already know it, but even then I just want to explain so that it's easy when we are working out with the program. So HCF will form highest common factor. So we'll move backwards. First, let us find out the factor. I have taken two numbers 4 and 6. So we are going to find the HCF. So I'll write it down over here. So factors of 4, you know what is a factor already by now. So 1, 2 and 4. And factor of 6, 1, 2, 3 and 6. So we have found out the factors of both the numbers 4 and 6. Now what we'll do, move on to the second word, common. So we can see we have got 1 common and 2. So there are two factors, 1 and 2, which is common in both 4 as well as 6. Then the third thing, highest. Highest, we have 1 and 2. Out of two numbers, 1 and 2, 2 is the maximum number. So highest number. So HCF is 2. So this is the technique we are going to use in the program. And LCM, what we are going to do is, we are not going to dig in the method, but we are using the formula directly, because if we find the HCF, LCM can be used with the help of formula. So LCM equals to A into B divided by HCF. Now A and B over here are the two numbers. So this is how we are going to do. First we are going to find out the HCF and then we are going to solve the LCM. Now moving on to the program, we can see I have taken variable I for the loop, A and B for the two numbers, HCF and LCM to store the value of HCF and LCM. First thing, I am taking two numbers from the user. So enter the first number, put the number inside the variable A, enter the second number will be stored inside the variable B, and then we'll run a loop. Now see, over here loop can be run in two different ways. Number one, I equals to 1 and I is less than equals to A, or in place of A you can write B also, because HCF of two numbers cannot be greater than any of the number. It can be equal but it cannot be greater, so you can write either A or B. If you want to increase, like if you want to make the program much more better, what you can do, you can use the function like map.mean and select the minimum out of 2 and then put that value over there. That will decrease the complexity. The number of loops will be less. And I am incrementing the value of I by 1. So what happens over here is the number starts from 1 till the first number. So all the numbers will be coming over here one by one. And in the if statement, what we are doing is we are checking the modulus with A as well as B. Now see, the logical operator used over here is AND. So both the condition over here has to be true. That means the first number is 1. So suppose let us take A as 4 and B as 6. So 4 modulus 1 equals to 0. True. B is 6. 6 modulus 1 equals to 0. Again true. So what will happen? The value of HCF, so I'll just write it down over here. The value of HCF for the moment will be 1. Then the loop increments the value of I becomes 2. Now again, 4 modulus 2 equals to 0. True. 6 modulus 2 equals to 0. True. Again, both the statement true. HCF now changes from 1 to 2. Then the value becomes 3. 4 modulus 3 equals to 0. False. Now if it is false, we don't have to check the second condition, but even then I am doing it. 6 modulus 3 equals to 0. True. One statement true over here, one statement false, means false, because we are using logical operator AND. Now the value becomes 4. So 4 modulus 4 is 0. True. 6 modulus 4 equals to 0. False. Again one condition false, it will not go inside this if statement. So what happens? The final value of HCF becomes 2, because now the value of I becomes 5. 5 is less than equals to 4 is false, so it will come out of the loop. So this way the value of HCF is getting calculated. So we are checking the modulus for both A and B, and if a number that is stored inside the variable I is a factor of A as well as B, it is taken as HCF. And again we are going to the higher number. So this way we are going to get the HCF. Now after getting the HCF, LCM formula we already know, we'll just put the value. So LCM equals to A into B, which are the two numbers, divided by HCF. So if the program comes to find only the LCM, I'll suggest you to first find the HCF and then the LCM. After that simply we have to display system.out.println HCF equals to HCF and print LCM equals to LCM. So this is how we do HCF and LCM program. If the program comes, find only HCF, no need to do LCM. But if the question comes, find out LCM, you have to first find out the HCF and then use the formula to find out LCM. This is much more easier comparatively doing it directly with the formula of LCM. So I hope you have understood this program as well. Thank you guys for watching my video. I hope you liked it. The programs written over here are not complete. So if you want the complete program, you can download it from the link given in the description. Any doubts, queries regarding anything, you can just mention that in the comment section given below. Now with this we come to the end of number programs. Now next what I am going to do is I will be coming up with some string functions as well as string programs. Okay, because some of you have also requested me to do that. So I will be doing that. That will be the next thing that I am going to upload. So till then, please don't forget to stay tuned, stay at home, stay safe. Thank you guys for watching my video. If you like my video, please hit the like button. And don't forget to subscribe my channel, Accidental Teacher. Now for any reason, if you have to go outside, please don't forget to put this on.